In the next two lessons we're going to look at what's called sacrificial and cathodic protection. Now, to start us off, let's imagine that we've got an iron pipe that's buried underground and we want to protect that pipe from possible rusting. Okay, so what happens when iron rusts? Well, oxygen that's dissolved in water, which is present in the soil, will oxidize the iron to produce iron oxide. So we have iron plus oxygen that's dissolved in the water that's present in the soil will produce iron oxide. Okay, what then happens, as you'll see in the video on iron and rusting, is that the iron oxide becomes hydrated by water, which then produces rust. So rust is really hydrated iron 3 oxide. So during this process what happens is the iron loses electrons to form an iron 3 ion plus 3 electrons. So this process is called oxidation. Because the oxidation state of iron has been increased to 3+, and in doing so it's losing electrons. So what happens really in the oxidation process is the oxygen in the soil gains these electrons to form oxide ions and then combines with the iron ions to form iron oxide. Now, if we want to prevent this oxidation process from happening, we need to find a way of stopping the iron from losing these electrons and becoming oxidized. Okay? And there are two methods which can be used to prevent this from happening. These are known as sacrificial protection, and this is the method we're looking at in this lesson, and the other method is called cathodic protection, which we shall look at in the next lesson. So the idea behind both of these methods is to stop this oxidation process happening, is to stop the iron from losing these 3 electrons. So let's look at sacrificial protection. So using this method we're going to form what is basically a voltaic cell. We're going to connect the less reactive metal, which is undergoing oxidation, in this case iron, to a more reactive metal. So in this case we'll choose zinc, which is just above iron in the reactivity series. So the more reactive metal becomes the anode, and the less reactive metal becomes the cathode. And in this symbolic diagram they're connected via a conductor. And so the anode is going to acquire the negative charge, while the cathode, that's the iron pipe, will acquire the positive charge. And electrons will be pushed from the more reactive metal, that is, the zinc, to the iron pipe, that is, the less reactive metal. And both the cathode and the anode are immersed in an electrolyte, which is the water in the soil. So while we've got electrons flowing around the circuit, we'll also have ions flowing between the cathode and the anode. Now the whole point of this process here is that electrons are being pushed from the anode onto the cathode, which is the iron pipe. And because the electrons are being pushed into the iron cathode, it stops the iron from losing electrons. So we can see that the iron, in order to be oxidized, it needs to lose electrons, but it is unable to do so because it's receiving electrons from the more reactive metal. This metal is the sacrificial metal. Let's make a note of that. So in sacrificial protection, the iron cannot lose electrons, that's to say it cannot be oxidized, because it's receiving electrons from the more reactive metal. So what's going on here then is that instead of the iron being oxidized, the zinc is oxidized instead. So the zinc loses its electrons and forms a zinc ion, and that dissolves in the electrolyte. So at the anode we have this half reaction taking place. So we have zinc is being oxidized plus 2e minus. Okay, and these electrons are pushed around the circuit to prevent the iron from oxidizing.
Now, as a result of this, the zinc anode is effectively being corroded. So the more reactive anode corrodes. And for this reason, the process is called sacrificial protection. That's to say, we are sacrificing one metal to preserve another.
Now in practice, the way this method works is that the sacrificial metal is literally bolted on to the object that it's protecting, so that it's not actually welded but is in close contact with the other metal. In doing so, there will be regions of contact which complete this part of the circuit, and there will be gaps that are separated with an electrolyte. Let me just give you an illustration. Okay, for example, here is a zinc sacrificial block that's been bolted onto the iron hull of a large ship. And so the hull may have a number of these blocks all over the place that are normally fitted to the ship in such a way that it reduces water resistance as the ship moves through the water. Okay, so there you go. And this is sufficient to set up this sacrificial protection process that we've looked at in this lesson. Okay, so in the next lesson we're going to look at the other way in which this oxidation of iron can be stopped, and that is called cathodic protection.